Hello everyone. Hello everyone. Hello GATE aspirants. How are you guys doing? Welcome to the GATEvantage series, and we are going to discuss today engineering mathematics, and in that we are going to discuss two very important concepts, limits and maxima and minima. So guys, as you might be seeing some action on the channel, the GATE Academy YouTube channel, and we have launched GATEvantage series, which is going to help you pinpoint those important 22 concepts for GATE 22. Out of those 22 concepts in mathematics, we are going to discuss limits and maxima and minima. The agenda for the session is going to be, guys, we'll be discuss some practice question with the concepts on limits and maxima and minima, followed by some amazing GATE question, mainly from IIT Kharagpur, because we know that IIT Kharagpur is going to organize the GATE 2022. And last but not the least, we are going to play a live quiz. I think you guys must be aware of that. We are doing some amazing quiz in the end. So be excited, stay tuned. Okay, so I think this is the right time to introduce myself. Guys, my name is Akash Charan. I'm an engineering mathematics subject matter expert. Have been guiding students, mentoring and teaching them for more than a decade. And that's all for, I think, a quick introduction. So guys, let's get started with the topic limits. So if I ask a question to you guys that why do we need limits? Why do we need limits? So my eyes are on the chat so that I can see that what are you guys responding there, okay? So why do we need limits, guys? What is the reason for studying limits after functions? And in the meantime, I would request you guys to keep sharing the link with your friends so that every GATE aspirant in this country should be benefited by this discussion. So, good evening, Kavya. Good evening, Ayush. What do you guys think? What is the reason for using limit? So guys, I think in the limit, whenever we are trying to do limits, right, the question comes with a graph which is of a particular nature. So if you look at the sin x by x, okay, look at the graph below, you will understand that when we are trying to do limit x tends to 0 sin x by x, okay, and we are trying to look at x equal to 0, so you know that it is going to be in trouble. What is the trouble here? As you are trying to approach on the graph from the left hand side of the limit, okay, left hand side of the limit, if you approach x tends to 0 from the left hand side, okay, then you see that the graph is giving you what? 0 by 0 form, right? And that is the reason that we cannot estimate the value of this function as x tends to 0 from the left hand side or the right hand side. If you come from the right hand side, the situation is same, because if you see here at x equal to 0, right, the graph is not continuous, the graph is actually having a break point. I hope you guys can see that. Now if we look at this, right, and we are supposed to find the limit, because it's such a very famous function you use in communication system, it gives birth to sync function. So in communication system, guys, you might have heard sync of x, which is a very, very important function, which is sin pi x by pi x. So we are in need of using this function, so we need to estimate what is going to happen as x tends to 0. As x tends to 0, the limiting value is 1, but the function is discontinuous. I can also show you this below below the table. If you follow, I can also show you from taking some random taking some data around 0. So if you see, I keep going close from the positive side of the 0, meaning to say I'm going to 0 from the right hand side. If you see, as you go close and more closer, your value is getting more closer to 1, isn't it, guys? Right, your values are getting more closer to 1. Then we say that, okay, this function might be discontinuous at x tends to 0, but it has a limiting value 1. Then some of you might be wondering that what if I take x from the negative side of it, meaning to say if you take x as 0.01, 0.001, if you go more closer from the negative side, still because sin x by x, right, sin x by x is what going to be negative for negative values. X will be also getting negative for the negative value, and then it cancel each other and you get the one value. Does it make sense, guys, to you? I hope so. In the meantime, I would also like to show you guys, right, in the meantime, I would also like to show you guys one question, and I want to understand from the people who are watching this session that how good are you with the basics of the limits. So you're seeing on the screen is a simple question on limits, and let me know what should be the answer for this one. So definitely we are going to discuss limits in detail in coming few minutes, but in the meantime I want you guys to do this question. So I'm looking for the answer, and please give it a shot, guys. Idea is to define this function. You're looking at a modulus of x by x, and you have to define this function, and it will give you some idea. Any answer? Vishal, Shrikant, Akash, Ganesh? So to help you guys, what I'm going to do, let me define this function which is mod of x, and it can be defined with the help of mod x by x, right? It can be defined with the help of mod x. When x is greater than 0, your mod x opens as positive, which means to say x by x, which is 1. When you take x less than 0, it is what? Minus x by x, which is minus 1. Definitely, you can also check here, the moment you put 0 here, you get a form of 0 by 0. Later on, I would say that 0 by 0 is an indeterminate form. But for the time being, I'm going to leverage your knowledge of limits. We are talking to the bright minds in the country, and I believe that you guys totally know what is 0 by 0 form. But definitely, we are going to work on that later. But as of now, if you guys look at here, 1 and minus 1, what do you guys think? What is the limit for this this function? And it would be happy to see that if you guys can draw the graph as well. So if I have to draw this graph, right? So what I'll do, for the positive of the x, it is, right, for the positive x, it is 1. For the negative x, so guys, this is your x, which is the positive x. For the negative of the x, which is what? Minus 1, right? What do you guys think? Limit does exist or not? If you look at here, from the right hand side, your function is approaching to where? It is approaching to 1. So right hand limit comes out to be 1. If you approach from left hand side, your left hand limit comes to minus 1. And since we know that as per the definition of limit, that LHL is not equal to RHL, right? Hence limit does not exist. I can say that limit does not exist. And indeed I have some answer, right answer from Naga, Pradeep, okay. Some of you guys are saying 0, 1, but the answer is limit does not exist. So guys, it is very simple to understand. For any given limit question, right, you have to look at the function or the graph and try to approach both the side. If you try to approach both the side, it should tend to the finite same value. So that means we can define limit as what? The left hand limit. What is left hand limit? Approaching the point from left hand side, and what is the function value? Should be equal to right hand limit. And don't miss this important point. That's why I'm going to write in green so that it is very much highlighted, that it should be equal to finite value. If it is equal to infinite value, again limit does not exist. This is very simple. Then you have to understand in limits that whenever we write limit x tends to a f of x, as you can see in this example on the left hand side, and we say that limit value is equal to L, so we believe that limit is existing, it is equal to left hand value and right hand value both equal to L, and L is a finite value. But the key call out here is that this term x tends to a. a lot of people miss to know that x tends to a implies x not equal to a, or you can write in other way, x tends to a does not imply x equal to a. Are you getting guys my point? So in limits, x tends to a does not mean that you will go and take that value, because there the limit is, their function is not defined. It is not even the domain of the function, so you cannot take that value. So that's why you will try to gauge the value from the left hand side and right hand side and come to a conclusion. Make sense guys? Okay, so there is one more point I would like to highlight here as a key concept, that limit does not exist at boundary point. Limit does not exist at boundary point. So what is a boundary point guys in a graph? So boundary point means that if you look at any function that will be defined on a certain domain for the x values. So the minimum value and the maximum value for which the function is defined, that is what we call it as boundary point. Limit does not exist at the boundary points, but appropriate one-sided limit exist. I can take an example to highlight this. If you come here, right, and let me draw any simple function graph. Now this is your boundary point A and this is another boundary point x equal to b. If you look at that from the left hand side, and if you are trying to find for this function what is the limit, for this function if you are trying to find what is the limit as x tends to a minus, right, so what I'm trying to say, suppose I give you this question, a drill question, that what is a minus for this f of x? What do you guys think? Come on. What do you guys think? If I ask for this graph, what is limit x tends to a minus, meaning to say I am trying to approach this a from left hand side. The answer is what guys? The answer is limit does not exist. But for the same function, if I try to find limit x tends to a plus, right, you can try to find that what is the value from this side, because it is anyway on the function and you can find some value, right? Getting guys clear? So that's where it is going to be very useful when you do continuity questions. So in continuity, if the continuity is about the function is continuous, it does not have any breakpoints, and at boundary point even the function is continuous, so how will you check with the help of limit? Because they are using the concept of limits as LHL equal to RHL equal to function value at a. If the function value at a, if you can't equate it to one of the limits, then I don't know how will you check limits with the help of limit, the continuity. And that's where you have to take one-sided limit guys. Does it make sense? Clear? Cool. Now I would like to invoke another topic here, which is infinite limits and limits at infinity. So as you have seen, limit x tends to 0. In the similar fashion, you can also look at limit x tends to 0 when the limit is getting the value infinity, or when you are trying to find limit as x tends to 0, as x tends to infinity. So let me take a function to highlight this. Suppose if I take a function which is a very famous function 1 by x when x is not equal to 0. Correct? This is a very famous function and it is known as what guys? Rectangular hyperbola. And I hope a lot of people will be 100% knowing the graph for this function. And in case you don't know, this is a good time to take a look at it. So let me draw the graph of rectangular hyperbola, which is this. So I'm drawing with my hand, so ignore the bumps and in the graph. Can you guys see that? This is x equal to 0. Now tell me guys, for this function, right, what is the limit when x tends to 0 at this point? So limit x tends to 0, 1 by x. Limit x tends to 0, 1 by x. What do you guys think? Come on, come on. Vignesh, Mojesh, guys, come on. Limit extends to 0, 1 by x. I think it's pretty simple. The moment you get any limit question and fortunately know the graph, it becomes very easy. What I'll do, I'll go and try to approach from right hand side. The moment I approach, you also try to approach the graph. So you can see that you are approaching where? You are approaching to plus infinity. So it is very clear that right hand limit is what? Infinity, guys. Come on. When you try to do the same thing from the left hand side, so let me use some other color here, and you can see that graph is going where, guys? This is not infinity, this is minus infinity. So LHL is what? Minus infinity. And since RHL is not equal to LHL, see why I'm laughing here, I would say why I'm smiling here, because RHL is not equal to LHL is different thing. These are anyway infinite values, this is not finite. So RHL is not equal to LHL simply tells that limit does not exist. For this graph or this function, limit does not exist. Make sense, guys? Very good. So I really see a lot of right answer. It thrills me much. Come on, Sihana, Pavitra, Mojesh, all of you guys are right. Amazing. Now tell me, if I say, what is the limit for the same function? What is the limit x tends to infinity? Come on, guys. And similarly, if I ask, what is the limit x tends to minus infinity 1 by x? So this is question 1, drill question 1 on the concept. What do you guys think? Limit x tends to infinity for this same function. What do you guys think? So how do you check that? In the meantime, you are doing it. How do you check that? If you are trying to go to infinity, right? It is going to where? It is going to where? 0. Right? Similarly, if you go to minus infinity, if you are trying to go to the minus infinity, right? It is also going to 0. So you can find the limit, and these are what? These are not your two-sided limits. Can you guys see that? Is there something on infinity that you can go other side and see? No, you cannot do that. Similarly, you cannot go to minus infinity and see, right? You cannot do that. So it is going to be one-sided limit, right? So if you have to be very careful, I would say this is going to be 0 plus and this is going to be 0 minus. If the gate is very smart, like IIT JEE exam, they will tell you that answer is 0 plus or 0 minus. But I think answer will be 0 in the option, not 0 plus or 0 minus. So you can do away with 0 only. But to be very precise, I think somebody has written that. Amazing. Mojesh, really appreciate you, man. Hats off. You are so true in this concept here. 0 plus means 0.001, approaching 0 from the positive side of, and 0 minus is minus 0.1. Very good, Mojesh. So I really see some bright minds in my session. Cool. So far so good, guys. So we just talked about quickly. I know some of our friends are joining little late. So we have just understood what is the limit, how does it work, where you can find limit, where you cannot find limit. I think those kind of concepts we have discussed, and then we just discussed what is limits at infinity and infinite limits. Now I'm going to talk about indeterminate forms. Okay, so as you can see on the screen, indeterminate forms will occur in any of the function when you put x equal to 0. In the moment you put x equal to 0, we get one of the following 7 indeterminate form. A lot of time people think it is 8, sir, it is 6. Don't do that. If you are saying 8, you have actually developed something in mathematics. You can be a great mathematician. There are only 7, and to remember it, you can remember the MSD jersey number. What is his jersey number, guys? Mahendra Singh Dhoni. It's 7. So there are only 7 indeterminate forms. Focus on it. What are they? These are very common. Every bacha in the maths, they know that. Infinity by infinity, 0 by 0 form. These are the two pair of the determinant forms where we are going to also apply Lapitel's rule. It is not L hospital, right? Lapitel's rule, but we write it as L hospitals. But it's up to you guys if you can say that L hospital. I don't have anything against it, but the right way to pronounce it is Lapitel's rule. Okay, these are the two indeterminate forms where they use Lapitel's rule. Then we have infinity minus infinity, 0 to the power 0, 0 into infinity, infinity ki power 0, and 1 ki power infinity. I am really seeing a lot of questions in these, I think last 5 years on this, These are the ones which are always hit. So these are the three forms you can never ignore in the GATE exam. I'm not saying that other forms will not be being questions, right? But I believe that these are the forms you have to take a look at. But I also have taken a question, later on I'll give you that question on this form, infinity minus infinity form, right? I'm also have taken, I think, a question on infinity to the zero form. So why I'm giving these information? So that you don't go away. I know it's 8:30 p.m., right? And it's night, might be tired from the college and all. Please stay tuned to the session. Stay tuned to the session. Okay? Now I'm going to talk about methods to solve limits. So one of the very important limit method is factorization. So let's take a question. Let's learn from the question. There's nothing to discuss more on the method. I'll tell you from the question. So take this question where I'm saying limit extends to pi by 4 of cos 2x upon 1 minus root 2 sin x. 1 minus root 2 sin x. What is the answer, guys? It is a practice question from my side. Let's see, it's not a GATE question, so don't get me wrong. So wherever I'm doing a GATE question, I am explicitly mentioning that it's a GATE question. And guys, share this link with your friends. Sharing is caring, that we know, and let's share it. Spread the news that we are doing GATEvantage series, and I hope if you share with your friends, and a true friend will benefit the other as well. So let's do that. And let me tell you the answer, I think in 30 seconds. What is the answer for this question, guys? So my eyes are on the chat. I'm looking for Pavitra's comment, Chandra, Mojesh. What is the answer? One answer already came from Arvind Raj. He's telling 0. Mojesh is telling -2, sir. Okay. -2, Mojesh. Can you check your calculation? Mrityunjay Singh, I think your answer is right. I want to build the suspense, so I am saying answer might be right. 2 is the right answer. I am hoping that Mrityunjay is right. Let's discuss this question, guys. Come on. So, as the name suggests, we are trying to do factorization. It means we are going to solve this question with factorization. But how will you factorize this? And that's where, if you are not good in the basic mathematical formula, you are going to suffer. And if, my dear friends, you are not aware what is the formula cos 2x, how will you do it? So cos 2x formula, who can help me here? Here the formula we are going to use is what? 1 minus 2 sin square x. The other formula is cos square minus sin square x, and the other one is 2 cos square x minus 1. See, I am very bad with formulae, but if you are seeing that I am making any mistake, please mention in the comment. Is it right, guys? Hello? So here I am not going to use these, so let me just clean it up. I am going to use only this formula, so I don't want to confuse you guys. And let's do this. So limit x tends to, I can do it here, limit x tends to pi by 4, and write cos 2x as what? 1 minus 2 sin square x upon 1 minus root 2 sin x. Then you know that a square minus b square. What is that, my dear friends? It is a plus b into a minus b. Use that. So limit x tends to pi by 4. Okay? And it will become what? 1 plus root 2 sin x and 1 minus root 2 sin x. Mojesh, I think you might have found your mistake, a silly mistake you have done, my dear friend. The moment I write it, and we know that we can solve this question without any hassle, right? We can do it very easily. So 1 plus root 2 and put the limit x tends to pi by 4. So it gives you what? Sine pi by 4. So it is 1 plus root 2 into 1 by root 2. So answer is what, guys? 2. Who got 2? Come on, let's be a quick yes or no here. Who got 2? I want to see the names. Who got 2? Mojesh got it. Mojesh, but I think you made mention -2. So that's fine, that's fine. The other approach is, my dear friend, rationalization. So rationalization can be very helpful. Suppose you are trying to do this question, you can also try with rationalization. So let's see that, are you able to do it, and mention in the chat. I'm expecting, my dear GATE aspirants, to try this question with rationalization and see how can you do it. So what is rationalization means? In this question, you are going to multiply with 1 plus root 2 sin x, right? Multiply and divide, right? Something like that. Not very famous method, so we can take a skip here. Then the third approach is, I think the 90% of the GATE question can be solved with the help of standard limit, my dear friends. 90% of the question can be solved with the standard limits. So let's have a quick revision of the formula here. So the first formula, limit x tends to 0 sin x by x is equal to limit x tends to 0 tan x by x, and both are equal to 1. I think every bacha knows this. Limit x tends to, that also true for sin inverse 1 by x and tan inverse x by x, that is also 1. One important thing that a lot of guys might not be knowing, that here x is measured in what? Degree or radians? Here x is measured in radians. So sometime GATE can, I think, if I recall correctly, GATE had asked one question there, they mentioned like something like this. So this is degree, guys. There you have to use your conversion, and I hope every bacha knows that pi is equal to 180 degree. So somewhere you have to use pi radian is equal to 180 degree, that relation, to solve this question. Then the third important one is limit x tends to 0, ln of 1 plus x by x, and the answer is 1. Okay. Limit x tends to 0, a ki power x minus 1 by x is answer ln a, and you should be knowing that it can also be written as log a to the base e. Don't write it as log a. Not a big blunder, but to be very precise, it is wrong. Don't write log a. Okay? That's not correct. If you use this approach, which is 8x a ki power x minus 1 by x, and then you replace a with e, which is your Napier's constant, you get the formula number 5. Isn't it, my dear friends? So what you are doing, actually, you are writing and replacing a with e, so you gave it what? 1. So a lot of time people remember this formula independently of formula number 4, but to be very honest, formula number 5 is a corollary of formula number 4. I would say a derived version of that, nothing else. You will not believe that once GATE asked this question as a formula, right? This question was a formula question, and GATE exactly at the limit for this one. I think it was in year 2008, if I recall correctly. So limit x tends to a, x to the power n minus a to the power n upon x minus a. If you guys see, all these are what form? All these are 0 by 0 form, right? Can you just put x equal to 0, and you will see all these are forming 0 by 0, 0 by 0, isn't it? Right? So here, if you see, how do I remember this formula? Then I actually came up with the trick. The trick is pretty simple, and I'm going to share with the whole janta here, that you take a to the power n and differentiate it with respect to a. So what I'm trying to say, if you differentiate a to the power n with a, what you get? You get n a to the power n minus 1, just like you do d by dx of x to the power n. What you get? N x ki power n minus 1. So it's a very good way to remember the formula. Then this is another form, which is 1 ki power infinity form, guys. Can you see that? Limit x tends to 0. The moment this gets 0, so it is 1 to the power 1 by x is infinity, so 1 to the power infinity form. The other way of looking at it is that you tend limit to infinity, and then you get 1 to the power infinity again, because the moment you replace x with 1 by x, so this is coming when you replace x with 1 by x, then you get the other formula. The answer for both the formula is same, which is e. Okay? This is another important indeterminate form that you should keep in mind. And the last one in my list is limit x tends to 0, 1 plus x ki power m minus 1 by x, answer is m. So here I'm trying to just give you something extra. You can ignore this, not very important, so you can also ignore this formula, but that's fine. Then guys, I'll talk about graphical limits, and this is nothing sort of which you can miss. Graphical limit is nothing something which you can miss. I know a lot of time people think that where we are going to use graphical limits. So graphical limits are going to be very helpful when you see limits like this. So limit x tends to infinity, and let me help you with some amazing concept here. So if you know that this graph is e की power x graph, this graph is y equal to x, sorry, I think I have to, yes, and the other graph is ln x graph. I think every bacha knows this graph, right? So at infinity, e की power x is a huge value as compared to x or ln x. And if you compare x with ln x at infinity, x is a very huge value. So I can give some example to make my point. If you take ln or take log of 1000 or maybe 1 lakh, it is just 6, isn't it, my dear friend? Even if you take log of 1 lakh value, which seems to be a big value, the answer is 6, only 6. But if you compare this as x equal to 1 lakh, right, it is a huge value. And that's where when you get a question like this, right, you are not going to or able to be solved by some method or some formula. You have to use concepts of graph, and that can be very useful. I have seen especially computer science students are being asked question on this concept. So what is the concept? It is pretty simple, that limit x tends to infinity for x by e की power x is 0. Similarly, you can write limit x tends to infinity ln x by x is also 0. So what is the idea I'm trying to highlight here? That the moment x tends to infinity, e की power x is a huge value and x looks like a baby here. So if you divide a big value, divide a baby with a big value, it will tend to 0. It's just like saying 1 lakh by infinity is 0. Similarly, you are trying to come up with this. Okay? So keep in mind, very important. Now guys, what I'm trying to say, if you look at here, then all these limits formula can be replaced, right, with some standard formula can be replaced with something else. So what I'm trying to say, right, everywhere, right as a note, everywhere, right, you can replace x with some function, x with f of x, and you can still use the standard formula, and get the limits. The only condition is that form remains the same. So if your question originally is 0 by 0 form and you are using some standard limit, form should not go from 0 by 0 to infinity by infinity or some other form, and still you can use that same formula. Then the next topic which I would like to highlight here, guys, is Lapitel's rule. So I'll quickly give an idea how does it work. I know most of the guys are already aware of this Lapitel rule. So Lapitel rule are only useful when you are looking at limit, 0 by 0 or infinity by infinity. So let me highlight here. So you are only going to use when you have a limit of the form 0 by 0 or infinity by infinity form. And what is the approach says that if your function is having this form 0 by 0, you can differentiate it numerator separately. That's why you're getting f of x is giving you f dash x, and similarly you're getting g dash x from g of x, and then you will again check that whether that indeterminate form is gone or not. If the indeterminate form is not gone, you will do it another level of differentiation, and it will go from f dash x to f double dash x divided by g double dash x, and you will do till the time you go and get the determinate answer. Make sense, guys? Clear? So to test that, let me give you a GATE 2014 question, and on the screen let me highlight that it is from IIT Kharagpur time. So in 2014, guys, if you know, IIT Kharagpur organized the GATE exam. So let's take a look at this question and tell me the answer. Urvesh, Siddhali, Mojesh, what do you guys think? First of all, never ever miss to check the form of the limit. If I have to help you a bit here, if you put x tends to 0, so I get 0 minus sine 0 upon 1 minus cos 0. So essentially I get 0 by 0 form. Right? What is the answer? What are you guys thinking? Any answer, guys? Mritunjay has answered 0, means option A. Okay. Anybody else? So I'm getting a lot of zeros. Okay, let's see. So guys, first of all, it is 0 by 0 form. So we can, without any doubt, we can use Lapital Rule. So if I use Lapital Rule, so what I'll do, I'll differentiate it. So it will become 1 minus cos x upon 0 minus of minus sin x. So I get limit x tends to 0, 1 minus cos x upon sin x. Isn't it, guys? Now again, if I put that x tends to 0, I get what? 0 by 0 form. So I have to re-differentiate it. I have to go one level down. So I'll differentiate it one more time. So it is 0 minus of minus sin x. And sin x differentiation is what, guys? Cos x. So I get limit x tends to 0, tan x. Sin x by cos x is tan x. The moment you put 0, answer is 0. So good. I think almost all of you guys got it right. Answer is option A. So just imagine that you have got 1 marks here. Okay. Very nice. Let me give you another question on the screen, guys. Can you take a quick look at it? Limit x tends to 0, tan x minus sin x by x cube. So this question essentially talks about a very important thing, that not every time Lapital Rule is going to save you. You can try using Lapital Rule here, but trust me, it will be too much to handle. Trust me. So why Lapital Rule is not a very good choice here? Because you have to differentiate 3 times. Can you see that, guys? X cube means you have to do 3x squared, 6x, and then 6. Because before that you don't get the form is it is not going to go away. So what I'm trying to say here, rather than using Lapital Rule blindly, take a call, take a decision. Do you guys agree with me? Do you guys agree with me? Come on, do you guys agree with me? So if you try Lapital Rule, you can do that. This is of 0 by 0 form. Nobody can stop you, because tan 0 is 0, sin 0 is 0, divided by x cube, which is also 0. So you can apply Lapital Rule. Nobody is stopping you. But it is going to take, sorry guys, I need to get this battery icon here and tell me. So if you see here, the idea is not to apply Lapital Rule. I hope you guys agree with me, because if I try to do that, it is going to go in a long approach. And in GATE, we have to do a question, maths question, generally in 2 minutes. So what I will suggest, you just split it up, tan x as sin x by cos x minus sin x by x cube, guys. Come on, and take sin x as common. Can I do that? Yep. So take sin x as common. So it is what? 1 by cos x minus 1 upon, give 1x here and do here. Something like this. So it comes out limit x tends to 0, sin x by x. And this is what? 1 minus cos x by x square. Okay, guys? And don't forget to write, I think, cos x here. Now this is a very classic formula. I think every bacha should know this. So let's take it as a drill question. So guys, before we complete this question, I want you guys to solve this question. It is also a GATE question. I think it was asked in GATE 2012. GATE 2012. Can you guys tell me the answer for this one? So I'm taking a break here. It's like a subroutine in here. I'm just taking a break to answer this question first. What do you guys think? Here you can apply Lapital like this. So you apply Lapital's rule, what you'll get, because this is also 0 by 0 form. So limit x tends to 0, what do you get? Bolo? You'll get what? Sin x by 2x. In one shot you can get the answer, and answer is what? Half. Come here and plug in. This is also a way to solve limits, right guys? So what is the answer the moment you put limit x tends to 0? So this guy, sin x by x into 1 by cos x and 1 minus cos x by x square. My suggestion is, guys, to you that you remember this formula, okay? You remember this formula, 1 minus cos x by x square. It should be in your mind as a standard formula, and the answer is what? Answer is half. Okay? So if you use this formula here directly, and just hope that you know that in the GATE exam, it can be like a game changer. Because you're going to save, I think, at least 1 minute, right? At least 1 minute. So it is 1 by cos 0 is 1, this is half, so answer is 0.5. See? So it can be a good question. I'm hoping every year that one day GATE asks this question. This is my wish. I have been doing this question for a decade now, but still that question has not been asked yet. Okay. Cool. Now guys, this is a good time to quickly give an idea about properties of limits. This is not something that you don't know, but I want to give you a good overview of the properties of limit. It's very simple. As you can see on the screen, limit x tends to c, f of x is L, and the other function g of x, limit x tends to at the same point is m. Then there are certain properties. So like addition, subtraction. So you can, already you guys are aware of this, but let me tell you that there are two functions and you can calculate limits separately and add it up. You can subtract the limit values. You can also do a scalar multiplication. K is a scalar, right? You can also do the product of the limits. You can multiply the L and M, right? You can also do a division rule or quotient rule where you can divide L by M, but you have to be a little careful. That's why I'm highlighting with the red, that the denominator cannot be equal to 0. The moment denominator gets 0, it is infinity. So you cannot afford that. So you have to be careful about that. Then power rule. Power rule is very easy to understand. So what we do in power rule, guys, so suppose you know the limit of any function as x tends to c, let's say L. So and you are doing some square or a cube or to the power 4, you can just do that same for the limit value. Okay. So what I'm trying to say, I can take an example. Down the line, if somebody asks you what is the limit 1 minus cos x whole square by x to the power 4, what do you guys think? Come on, let's see who has understood this. If I ask you this question, limit x tends to 0, 1 minus cos x whole square upon x to the power 4, what is the answer, guys? Come on. GATE recently used a concept on this. What is the answer? What do you guys think? My eyes are on the chat. What is the answer? I think answer is simple, 0.5 to the power 2. So answer is what? 0.25. 0.25. Mujhe it's not 0.025. I think 0.25, right? 0.5 into 0.5 is 0.25. You have gone to 1000 place. So don't do that. Isn't it? Okay, cool. Now, I think graphical limits I have already covered. Now, this is the GATE question which we have already solved. So I'll go happily and answer it. What is the answer, guys? Half, right? So far so good, guys. Any question, any doubt? I can take a small pause here. Any question, guys? Kavya, Pavitra, Mrityunjay, Mojesh, Sai Prakash, any question, guys? Okay, now I think in case if you have any question, keep commenting. I'm constantly looking at your chats. Okay, if I talk about what is the 1 to the power infinity form, it is very, very famous form, very common form, and how to tackle it. So I'm going to share a very detailed equation to highlight it. So this you can take it as a result. So let's say if I say limit x tends to a, f of x to the power g of x. Okay, f of x to the power g of x, right? So on this, if I try to find what is the 1 to the power infinity form, so to do that I am saying where f of x tends to 1, because I want to reach to this form, fx tends to 1 as x tends to a, and g of x tends to infinity as x tends to a. So the moment this verifies that it is a form of 1 to the power infinity, so the result that you can keep in mind to solve any general limit, I am giving the formula. You don't try to prove it and all at this point. You just use the formula, you will never be disappointed. So it is e to the power limit x tends to a. A lot of times students miss this, so let me highlight it. E to the power limit x tends to a, g of x into f of x minus 1. This is all in power. Okay, so you can use this formula as a ready to use formula and you can answer any question on this form. Let's try this and answer the very first question on the screen on this form. So limit x tends to pi by 4 tan of x to the power tan 2x. What do you guys think? What should be the answer? But don't be in a hurry. Before you answer this question, you should be able to verify the form. What is the form here? Tan pi by 4 raised to the tan 2x means tan 2 into pi by 4. So it gives me what? 1 key power, and this is tan 90. So I'll get infinity. So done. This is 1 to the power infinity form. So guys, to get this, what do you guys think? How will you solve it? Use the formula. So I am going to help you a bit here. That here I can see that f of x can be taken as tan of x. G of x can be taken as what? Tan 2x. Isn't it, guys? So I'm giving you guys a moment to get the answer. Don't disappoint me. I hope you can do this. Definitely you can handle. Bhagyashri, Mojesh, what do you guys think? What should be the answer here? Come on. So I got the answer. Answer is e to the power minus 1. Urvesh is telling. Mojesh is telling e. Okay. So I'm getting multiple answers. I'm getting e. I'm getting e to the power minus 1. I can create options out of it. Okay. Somebody is infinity. Somebody is saying 1 or minus 1. Mojesh is retracting his messages. Okay, let me solve, guys. It's okay. So e to the power, what should I do? This is f of x. Okay, this is g of x. So tan 2x is g of x. So bring it down. So write tan 2x into tan x minus 1. Okay. So this is e to the power tan 2x into tan x minus 1. Then you should be able to solve this, because I hope you guys know what is tan 2x formula. Anybody can write in the chat. So the tan 2x formula is what? It is 2 tan x upon 1 minus tan square x. That's why I'm telling, if you are not good with formula, forget about GATE exam. So the idea is to remember all the formula. So I can write it here, 2 tan x upon 1 minus tan square x into tan x minus 1. Okay, then it's like a baby maths here. Any bacha can do. So it is e to the power 2 tan x, then apply a square minus b square. So you'll get 1 plus tan x. In the denominator, you'll get 1 minus tan x, isn't it? And then take minus common from this term. So you'll get minus outside. And then write it as 1 minus tan x. Why did I do it? Because I could see that I have to bring it in the same form so that I can cancel it. So it is what, my dear friend? It is e to the power minus 2 tan x upon 1 plus tan x. So if you put the limit extension, and don't, obviously we have to put that limit. So in the case, if you are seeing that I have not put the limit, So don't worry, it is there. It is understood that we are going to put the limit. So in case somebody comes and say, hey, come on, where is the limit? So here is the limit. So it is in our psyche, it's our in subconscious mind. Thus put the limit. So answer is what? Minus 2 tan x tan pi over is 1 upon 1 plus 1. It is what? E to the power minus 1. I think somebody said e to the power minus 1. Who was that person? Mojes, Urvesh. I think big hand for these guys, because that's the right answer. And these are some amazing questions. Now take this question, GATE 2015. GATE 2015 question, guys. Come on. A similar set of question I am showing on the screen, my dear friends. Limit x tends to infinity. Limit x tends to infinity 1 plus 1 by x to the power 2x. What do you think? What is the answer here? Always so fast, huh? Question 7, he is telling answer is D. Option D. Okay. E to the power 2. Okay. So let me solve it. Can I solve it now, guys? Okay. I'll do a verification here. So I know it is limit x tends to infinity 1 plus 1 by infinity 2 into infinity. See, this is not the right way to do it, but we are doing it anyway. So it is what? 1 to the power infinity. So it is 1 to the power infinity form. So we are happy we can use the formula I have just shown to the guys. How we are going to use that formula? What is the formula here? Come on. It is E limit x tends to a. So you have to again think like that this whole thing, this yellow part is your f of x, think like that, and the green part is your gx, think like that, and then you do the rest. So how will you solve it? It is e to the power limit x tends to infinity 1 plus 1 by x, right? Or I would say right in the way we have learned, 2x 1 plus 1 by x. So this is your gx, this is your f of x minus 1. So these two cancel each other. So it is what? E to the power limit x tends to infinity 2x into 1 by x. X cancels each other. So answer is what? E to the power 2, which is e square. I think most of the guys have got it. Amazing. I think this is almost one of the last problems in limit. I think this is what I have planned. Let's see who gets this question correct. Excuse me. So you are looking at limit x tends to infinity root under x squared plus x minus 1 minus x. What do you guys think? First of all, verify the form. Are you able to verify that it is 0 by 0 or infinity by infinity, or what form it is out of those 7 indeterminate forms? If you think that it is any of the forms which you have seen till now, let me know. So without solving the question, you have to first tell me what is the form. I will not take the answers in the comment if you don't tell me the form. I am interested in knowing the form as well. I know this is not the part of the question, but I am interested in knowing the form. So my eyes are on the chat to understand what is this form. What do you guys think? Come on. So before we go anywhere, it is x squared plus x minus 1. So definitely it is of the form, if you put the limit here, so it is infinity ka whole square, infinity minus 1 minus infinity, right? So it doesn't matter whatever it is, minus 1 or minus 100 also, you'll get what? Infinity minus infinity form. My dear friend, my quick advice, when you see a form like this, what you're supposed to do, the answer is, I think somebody answered that, Mojes has answered that, very good. Whenever you see a form like that, you have only left with one of the cool technique, rationalization. You don't need to learn it, you have to apply it, because subconsciously on your mind, you know what is this. So do that. So if I do that, I'll get what? Limit x tends to infinity. I'll take the surds conjugate of here. So this is like a minus x. So what I'll do, I'll take the conjugate of this, which is x square plus x minus 1. I'm not talking about complex conjugate, I'm just talking about conjugate. And I'll just multiply and divide it. So I'll get what? X square plus x minus 1 plus x. So think like this. This is your A, okay? This is your B, right? It is like A minus B, A plus B. Isn't it, guys? So do that. It's like a baby maths. So limit x tends to infinity, A square minus B square. So we will get x square plus x minus 1 because root A into root A is A, right? So it is, that's why you're getting the whole term as is out, and then minus x square divided by root under x square x minus 1 plus x. Okay, so these two cancel each other, so you are left with what? Limit x tends to infinity, x minus 1 upon root under x square plus x minus 1 plus x. What do you guys think? But now you get the form infinity by infinity. Let's stop here, right? If you put the x tends to infinity, so what is the journey looks like? The journey looks like that you have come from infinity minus infinity form to where, my dear friends? Infinity by infinity form. So is it your mind coming, is it your mind is thinking, is your mind thinking that can we apply Lapitel's rule? I think it will be a suicide. Do you think we should apply Lapitel's rule here, guys? Do you think we should apply Lapitel's rule here? I don't think so, because differentiating root is awful, right? So what is the cool technique here in infinity by infinity form? Let me write as an important note. That's what you're going to learn in GATEvantage series. We are proud of this initiative because this is going to help not one guy, two guys. It will help the whole country to achieve their dreams. Anybody who is a GATE aspirant is going to get help from the GATE Academy flagship initiative, which we call it as GATEvantage series. You have to take advantage of this series. You cannot miss any session planned for maths, aptitude, or any core subject, my dear friend. This is my sincere request. You can take it from Akash Sir that trust me on this. Whatever the session is going to come your way, you are going to get benefited. Trust me. You can write on a blank sheet of paper and you can tell me later that it will really help you. Because as a team, we are putting a lot of efforts and time to come up with the right flow of the concept. We are picking those concepts very carefully and trying to maintain this for the whole GATE preparation. So I guess, guys, 22 concept can change your life. It can be a game changer. And we are sitting in the almost on the mid of October, right? Almost, because 8th October is today. Almost in the mid of the October, you are just left with, I think, 3 or 4 months. I would say 3 on a conservative side. So you cannot afford to ignore these kind of sessions. So that's what I'm saying. Support us, like, subscribe our channel. You should tap the bell icon, because I know it looks like a more of a series of steps, but it's very simple. You can like and subscribe so that any session is coming up, you don't actually miss it. Okay. So answer C, Mrityunjay Singh is telling answer C 1 by 2. So before I go and tell you the answer, I have to tell you this amazing concept, my dear friend here. Let's come back here. Whenever you see infinity by infinity form and you are seeing some algebraic expression, right? The idea is to take the highest power common. Take the highest power of x as common, right, in numerator and denominator. This is amazing life-saving hack. You cannot ignore it. Some of you guys might be knowing it, right? So take the highest power x as common in numerator and denominator separately. Okay, obviously we'll do separately, but let me write it. So limit x tends to infinity. Take the highest power is x, so I'll take it common. Here it is x square. So let's do it and see what happens. So if you take x as highest power as common, so you'll get 1 minus 1 by x upon, take here x square as common, so it is what? 1 plus 1 by x minus 1 by x square plus x. Just hold on. Then this x square will come out as x, isn't it? So limit x tends to infinity, x of 1 minus 1 by x, and take this guy outside the root. So it is x root under 1 plus 1 by x. See, I'm going very detailed, and then you can take x common from here as well, isn't it, guys? Can you see it? So I have taken x not only common from this term, also from here. So these two guys will cancel each other, and the moment x tends to infinity, this will be 0, this will be 0, this will be 0. So answer is 1 upon root under 1 plus 1. So answer is 1 by 2, which I think a lot of people got it already, right? Answer is 1 by 2. So guys, this marks the end for limits, which I had planned. Okay. Now I'll go to the next. So before I go to the next important topic in engineering maths, which is maxima and minima, let me ask you guys, you have any question, any doubt, please ping it. Okay. Any of you guys, and I think my laptop charger is breaking, so just give me a moment, I'll plug in, I'll back in 1 minute, okay? Okay. Sorry for the inconvenience, guys. Let me go to the next topic which we had planned, which is maxima and minima. So maxima minima, I think it is one of the another very important topic in maths, and I believe not only in maths, if you're planning to do any I would say engineering courses down the later, MTech or MS, you are trying to do any job, there you are going to use maxima minima like anything. Maxima minima is something which you cannot afford to ignore, and I believe that maxima minima is something, right? If I can take example, suppose you're using computer science, guys are using gradient descent algorithm, which is a lot of time people try to solve a lot of optimization problem, right? So if I take example of booking a car on Uber, ordering a food on Swiggy, it is going to take maxima minima in the place. So you're trying to optimize, somebody is ordering a food on Swiggy, it looks at a lot of Swiggy delivery guys present in the area, trying to come up with that which delivery guy should be allotted to you. It looks at distance, it looks at who has already taken a lot of orders, and then try to optimize it and come up with one delivery guy being tagged to you. Similarly, if you're trying to do any any simple optimization, like suppose you are trying to go from let's say point A to point B in logistics or in supply chain, right? So you have to optimize the route, and that's why we call it as route optimization. You're also looking at a lot of maximum minima kind of concept, as simple as that you're trying to check in a luggage on Air India, and if you're trying to find out that what is the optimal size of the bag that I can take it and it should fit in the in the cabin luggage, so you're trying to take that bag into the aircraft itself. It has a certain dimension, and you have the dimension you can plug in into your concept and maximize that area. Makes sense, guys? So it is very, very important. Okay, it's very, very important. And also for GATE. So I think GATE keeps asking a lot of questions on maximum minima, and I believe, right, I believe that every other year, I wouldn't say that every year they're asking maximum minimum question, but every year you will see some question on maximum minima in mathematics or indirectly on any core engineering subject. So let me start with the concept, but before I want to take a look at the chat. So any question guys you have on your mind, let me know. I think we are good then. So guys, let me show you this graph on the screen. As you can see here, so if you see this function, right, can you see this point A1, which is having, which is having the highest value here if you compare it to the closest values, right? So let's say this is your point, let's say A1. At A1, if you see from left hand and right hand, this has the highest value. So we call it as local maximum. Why it is called local, guys? Because it is locally at the highest value from the left hand and right hand side values. Okay. Similarly, this point is a local minimum, right? This value is a local minimum value. Okay. Because if you compare this point, let's say this is B1, from left hand side and the right hand side, this is the lowest value it can get it. Make sense? So there are two kinds of concept in maxima and minima. So one is local and the other is global. Okay. So if you look at from the math side of it, right? So local is not something going to be helpful in GATE exam, but you should know as a concept. Generally, GATE questions are always based on global maximum or global minimum. So local means what? Local means if you are having a lot of maximum value or minimum value, all those are local values. But global, if I say, it is going to be the only value. So if you look at the graph, can you guys tell me that if I say A2 is what? Global maximum, which I have also written here. Can you guys see that? A2 is your global maximum and B1 is your global minimum. Can I say that, guys? Why I am saying A2 is global maximum and B1 is global minimum? Because B1 is the lowest value of all the local minimum values, right? So B2 and B1, if you compare, you get B1 as the lowest value. If you compare A1 with, right, A1, A2, A3, A3 is what? Sorry, A2 is what? The maximum value. That's how we define global maximum and global minimum. GATE always asks any of it. So they will ask, right, whether it is a global maximum value, fine for me. It is a global minimum value, fine for me. Okay. Let me show you one amazing graph here. How do you actually mathematically come to this conclusion that I know it is a maximum or a minimum value? How will you find it? To do that, I am going to invoke the discussion of the stationary points. Stationary points, also known as what? Critical points. So it has, 2-3 names. When you go from maxima minima from one variable to more than one variable, it also becomes, a stationary point also become from one dimension to two dimension. So meaning to say, here you will be looking at x because it is x, right? So this is a critical point x. This is another critical point x. But there you will not be looking at x. Actually, it will be two-dimensional. It will be looking as x, y. But as per the agenda of the session, we are not going into multiple variable. We are only looking at single variable maxima minima. So if you focus as x, what is your key observation? If you look at this graph, my dear friend, what is your key observation? What is your key observation? The key observation is that the moment this maximum or minimum comes, it gets flat. Can you see that, guys? Here the tangent is a horizontal tangent. Can I say that? Here the tangent is horizontal, which implies what, my dear friend? It implies that f dash at whatever the point, suppose you are looking at point A, so let's say this is your point A, let's say this is your point B, it gets 0. Isn't it, guys? Hello? Right? The horizontal tangent is 0, so you say that slope is 0, and that's what we call it as stationary point. The meaning of stationary what? Rest, at rest, at rest. So the moment graph is going up, which you can also see in the below graph, the moment the graph is going up, and if you keep drawing tangents, you can see that this is having a monotonically increasing, so your tangent is positive. Can you guys see that? The slope is positive, meaning to say here if you differentiate it, it is greater than 0. Can you guys see that? Here tangent is positive, you can always put theta to understand it, my dear friends. And if you go down, here the tangent is, right? Tangent is making an angle more than 90 degree. Here I would say slope is negative. Now this is amazing. This behavior which you are analyzing is amazing thing. And guys, I need your full attention on the screen, right? I know we are trying to do some chit chat in the chat, and I hope you guys understand that I'm also reading it. So I need your full attention. And if you see here, when the slope is increasing, right, your slope is like positive, then it goes into negative, you see something is happening here. So the moment your slope is like, you know, a function going from dy by dx positive means what, my dear friend? Dy by dx positive means monotonically increasing function, dy by dx negative means monotonically decreasing function. So in any graph, if the slope is increasing, dy by dx is going from positive to negative, so you have an increasing function to decreasing, what do you see on the top? You are bound to get a maxima. And at the top, your value is what? Your value of the slope is what? 0. And that's what we call it as critical point. Isn't it, guys, clear? Right? And similarly, if you go from MD to MI, what is happening? Again, here slope is positive, so means, right, the moment you go from decreasing to increasing, try to feel it. You are going from MD to MI. What do you see here? You see a valley here. You see a bottom point, which we call it as minimum value. That is what I call it as, in a very fancy language, first derivative test for maxima and minima. See? So a lot of time people say, what is first derivative test? Nothing. It's simple. You know it. What is first derivative test says? It says that if the first derivative changes from positive to negative, right? Positive to negative at a given point, then the point is determined as local maximum. Why we are not call it as global? Because we are not sure that this is the only part of the graph, right? It can also go very high, right? And then this becomes the maximum, global maximum. So you are not sure about it, right? That's what you are going to always say. On a safer side, it is local maximum. So when I say positive to negative, it means to say your observation point or critical point is let x equal to a, and your function, which is derivative dy by dx, first order derivative, if it goes from positive to negative, that's what I'm trying to say, right? So plus to minus, what happens? The moment it goes from plus to minus, you get what? Maxima. This is very helpful down the line. And similarly, if you look at here on the other one, right, at x equal to a, right, and then you are going from negative to positive. Look at the second statement. So meaning to say you are going from dy by dx less than to negative to positive, which means minus to plus. So you are going from MD to MI, right? This is like MD to MI, you get minima. Can you guys see that? This is like going from MI to MD. Are we clear? Are we clear on this, guys? Are we clear on this? Okay. And then the last result, if you take a look at that, if the first derivative does not change at any given point, then that point will not be considered as local maximum or minimum. Local maximum or minimum. Anybody can give me an example here? Can somebody give me an example here? Mojesh, Niranjan, what do you guys think? What is the answer for the third point I am making? So if your MI or MD is not changing, it is consistent, right? What would be the example where you will not find neither a maximum nor a minimum? What do you guys say? Come on guys, let me know. So I can give an example in case you are wondering what is that example. I can give an example, my dear friends. See, you have seen this graph, and let me know who has seen this graph. Have you ever seen this graph? It is a very famous graph, which is y equal to x cube. at x equal to 0, right? I'm trying to understand whether it is a maximum or minima point, right? So what do you see here? If you do the maths here, a bit of maths, it looks like a critical point because you have function x cube, you differentiate and put it equal to 0. That's how you find critical point. You get a critical point x equal to 0. But does it mean that it is having a maxima or minima? A lot of time people think the moment it gets 0, it is a maxima or minima. But if you look at here, that 3x square, which is your first order derivative, even if you put any number which is more than 0, put any number, right? It is always going to be positive. And if you put any number here less than 0, it is still going to be positive. Isn't it, guys? It is still going to be positive. So here, all the time, this function is what? Mi and mi. And that's why this is a very famous point. It is not a maxima or minima point. It is what? It is a point of inflection. Come on, guys. It is a point of inflection. What do you guys think? Come on. So this is a very common pitfall in maxima and minima. People think that the moment you get a critical point, it has to be one of it. It has to be a local maxima or local minima. Not necessary. Not necessary. You have just seen one example. Let me also show you another example. You guys know about mod x, right? So critical point does not mean that function first order derivative has to be 0. As you can see, I have mentioned on the screen, a critical point or a stationary point, not necessary that it will be equal to 0. It will never be, like, it can also not exist. If it is not existing, still you can get a maxima or minima. Let me show you this function. What is the graph for this function, guys? I think every bacha in the session knows this, right? What is mod x graph? Come on. Are we cool with the graph, guys? Mod x equal to 0. We know that at x equal to 0, mod x is what? Differentiable or non-differentiable? Non-differentiable, right? If at x equal to 0, this graph is non-differentiable, meaning to say that here derivative does not exist. First order derivative does not exist. So can I say that this point x equal to 0 is not a point, a critical point? Or shall I say that it is a critical point, although first order derivative does not exist, but GATE has asked one question, exactly the same question, and you should know that x equal to 0 is a what point? It is a local minimum. It is a local minimum point. So at this point you are getting a local minimum, isn't it, guys? Makes sense? Correct? So that is a common pitfall. People always get struggle with at least these two functions. And trust me, I have seen a lot of IITs interview, professors are asking, right, these two functions all the time. Tell me a function which is continuous but non-differentiable, mod x. Tell me a function which is not having a proper maximum minimum, but still it is a critical point, x cube. So just having a critical point does not guarantee a maximum or minimum. You can look at that. Now let me tell you the steps to find global maximum minimum, and this is going to be the, I would say, the Bible for finding maximum or minimum. So please take care of this concept very carefully, else you will miss a question on this. So let me show you on the screen an important thing here. Steps to find global maximum minimum. The first step is that find all the critical points in the closed interval a to b. You have to have a closed interval. In the question, if it is open interval, you can consider the question is not right, or they are not interested in the boundary point. These are the two options can be possible. If it is a closed interval means you will be looking at a square bracket, my dear friends. Can you see that? So if you look at the closed interval, which is a comma b, in this case you have to find all the critical point within the interval. Also find the value of function at the critical point as well as the boundary point. A lot of time people miss it, and GATE is using this step number 3 all the time. So what we are trying to say, don't only find the function value at critical point, also find the function value at boundary point, meaning to say calculate f of a and f of b, the boundary point values. Then how will you find maximum, global maximum? You take all the critical point values and the boundary point values of the function and see which is the largest value. The largest values from step 2 and 3 is your global maximum, The smallest value from the step 2 and 3 is your global minimum. Right? Makes sense or not, guys? Come on. And if you have understood it, let me give you the GATE 2012 question on the screen. Let's see who can do this. So you are looking at a function x cube minus 9x square plus 24x plus 5 in the interval 1 to 6. What do you guys think? What should be the answer? You are looking at the option 21, 25, 41, 46. GATE 2012 2 marks question. On the screen, guys. I think this is the time to take glory. Niranjan, Rajiv, Arvind, Mojesh. Come on, guys. What do you think? What is the answer? What are the steps? The very first step you are supposed to do at what? You have to differentiate this function to find the critical point. So there's 3x square minus 18x plus 24 plus 0. Don't keep 5 as it is. So and then put it equal to 0. So you'll get what? 3x square minus 18x plus 24 equal to 0. X square minus 6x. I'm taking 3 as common and putting it equal to 0 plus 8 equal to 0. So it gives me what point? It gives me, what are the values I'll get, guys? I'm trying to be little, little like a baby here. Okay, so ignore that. This I'm doing for all of you guys. So you'll get x minus 2 into x minus 4. So the critical points you have got x equal to 2 and x equal to 4. Cool. Now you guys will help me. What is the value of function at 2? What is the value of function at 4? And don't miss the boundary point. What is the function value at 1? And what is the function value at 6? You are supposed to find all these values, and it is easy to do because there are only 4 values. Come on. So what is the function value at 2? If I can find it quickly for you guys. Function value. So 2. Can you guys help me here? 2 to the power 3, 8 minus 4, 36. 48 plus 5. How much it is? 53 and 8. 61 minus, I think 25 I'm getting. What is the function value at 4? Okay. 16, 64. And what is the function value at 4? Come on, guys. I don't want to do this. This is very long. I'll struggle here. So it is 1 minus 9. I'm being smart. 24 plus 5. So I get what? 29, 30 minus 21. What is the function value at 6? Guys, come on, help me. Right, come on. See, this point has 2 critical points, x equal to 2 and x equal to 4. This function has 2 critical points. What is the function value at 4? Okay, nobody is helping me. I have to do it. So 16, 64 minus 16, I think 16, 9. So it is 144 plus 96 plus 5. How much is that, guys? So anyways, and what is value at 6? So 216 minus 36 is 9. So I'm doing the hard work. 96 is 54, 324. And please correct me if I'm making any silly mistakes here. And 144 plus 5, I think here you will get 41, right? And here you will get how much? So 400 gone. So 1 minus 43, 64 minus 43, so 1, 21. So I get 21, 21, 24, 41, which is one is the maximum. So I guess 41 is the right answer. And look at that, option A and B are already there. So if you think this is your maxima, which you can think later, that 25 is maxima, you will take option B, which will be wrong, absolutely wrong. So guys, one learning from this question, right? One learning from the question is that whenever they give a cubic function, mostly it is going to be on the boundary point, 99% I would say, or it will know maximum minimum. So cubic function, don't miss boundary points and check the interval whether it is square or not. If it is square, means they are including the boundary point, don't miss it. Okay? Now, second derivative test. So I want to keep it complete. So I'm also telling you what is second derivative test to find maximum minima. So second derivative test is pretty simple, guys. You know first derivative test, that tells you the critical point. Second derivative test tells you that if your function first derivative at c is 0 and double derivative at c is positive, think ulta opposite, it is going to be a minima point. So x equal to c is a minima point and f of c is a local minimum value. Similarly, if your f dash c is equal to 0 and if double differentiation is if double dash c is negative, think opposite ulta, so it is maximum. So x equal to c is a local is a point of local maxima and f of c is a local maximum value. These are the two results to identify maximum or minimum by using second derivative test. Although we have solved this question without using any second derivative test, which you can do all the time, but sometimes it's good to know. Then there will be a third case which will be coming up in the calculus as a concept called point of inflection, where you see both first derivative and second derivative are 0. Then your second derivative test fails and you are supposed to go back to your first derivative test and investigate it further. Make sense, guys? Let's take the recent GATE question on the screen. GATE 2021. GATE 2021 question, guys. Come on. Let's see that can you get a 1 mark here. Niranjan, Urvesh, Mrityunjay, I'm expecting from you guys. Arvind, Mojesh, constantly answering, fully active, guys. Big hand to you guys. Let me know the answer. What do you guys think for GATE 2021 1 mark question in from Maxima Minima? Come on, guys. They have given the interval. Have the checks ready. 5, 10 included, boundary point included. X square not a cubic function, means it is going to be a parabola, quadratic equation. What do you guys think? What should be the answer? It's a numerical answer type question. You are supposed to fill the number. What do you guys think? Come on. So first step is always same, right? You take the function and differentiate it. So if you differentiate it, you will get what? Minus 2x plus 10, right? And put it equal to 0. So you get a point x equal to 5, which is your boundary point, right? Which is your boundary point. What do you guys think? So you can say that it is a maximum or minimum. How will you check it? Do second derivative. You have just learned. You'll get minus 2, right? Differentiate it one more time. So f double dash x will give you minus 2. Doesn't matter if you put any point, it is absolutely always negative. So it is a critical point. Your double derivative is negative. It means what? Right? What do you guys think? I think it is not a minimum value for this graph. Minus 2x plus 10. Is it right? Okay, anyway, see what they are trying to ask. We can find it. F of 5, if I find minus 25 plus 50 plus 100, right? So it is 150 and 5 ka whole square is 25, right? And then 100. So it looks like it is a maximum, but what about you are getting a point, how much? 125. They are not asking maximum. It's a brilliant question, guys. Look at the other boundary point, guys. That's the catch here. Minus 100 plus 100 plus 100. So f of 10 out of these two. Come on. Amazing. Amazing question, guys. I'll put one more star. What is the minimum value, guys? 125, 100. Come on. That's what I've told. Don't miss it. The boundary point. Right, guys? So f of 5 gives you what? Minus 25. I'll do a quick validation. 10 is 550 plus 100. What is the value of f of 5? So it is what? 150, 125, 125, 100. Which one is the minimum value, guys? Come on. They're not asking maximum. Answer is 100. Who got 100? I see Urvesh has got it. Big hand for Urvesh, because you have got a very brilliant question here. See, it's not a cubic function. Still, they have used the boundary point. Amazing question, guys. Okay, so I think that marks our discussion for the limits and maxima minima. I am interested to initiate the live quiz, guys, and there I am going to show you 3 questions, and I would suggest you to fasten your seat belts. But before I go into live quiz, are you guys ready for the live quiz? Let me see some energy in the chat. Are you guys ready for the live quiz? Come on. Shall we go for the live quiz? Mojesh, Sihana, Mrityunjay, Niranjan, and all of my dear friends who are watching this session. Shall we go for the live quiz? Did you guys play the live quiz before this? So let me go to the live quiz. Can you see on the screen? Let me go to the live quiz view. In a moment you will be able to see on the screen. Let's go for the live quiz, guys. So guys, this is live quiz for limits, right, and maxima minima for GATEvantage series, and this is more like what we have studied, what we have done. We have covered good ground in last 1.5 hours, right? We want to see how do you guys progress on the questions. So let me go to the instruction. I think first thing first, guys, we have to go to this. You have to go to this bit.ly /TGA0002E. Can you guys quickly click on your mobile, type in this web address and go in there and log in. I'll give a minute here and let me know if you have logged in. In the meantime, I'll tell you how to play the quiz. It's very simple, very interesting. It is going to be the most amazing activity before you go and say yourself good night for the day. This is going to be the memorable experience. In this quiz, guys, I will be giving you some question on the screen, right? And everybody who is logging in, they can answer the question. They will put their answer in the portal which you are looking at. You might have a participant view at your end. There is no negative points for this question, which is I'm trying to keep it very simple because in GATE it is going to be negative marking. So there is no negative marking, no negative points. You will be seeing the number of points per question displayed along with the question. So for each question, how many points you are going to get, it will be displayed with the question. If you get more difficult question, you get more points, right? And as you answer fast, like faster you answer, the more marks you get. So it's like a competition of like something like speed and accuracy. If you are faster in answering the right answer the right thing on the question, you get more score. So let's get excited. Let's get started. I'm very excited. Let's see. So I'm just waiting for the players to join. And can you guys confirm that you have joined? So I can see Kavya. Come on, Kavya, welcome. Shihana, nice to see. Everybody has to participate. Okay, please don't run away. So we are doing great. Please don't run away. Ashok, Ranjit, there's nothing like right or wrong. Let's try it. Give it a good shot. Okay, everybody is there. Come on. Let me know once we can go. I'm seeing a lot of people are missing in the live quiz. So can I have everyone in the session, in this quiz session? You have to go to this bit.ly link on /TGA0002E. Okay. So let me start the quiz, guys. The first question, I think, guys, let me know if you are waiting for me and you are facing any issue in joining this. Let me know. I can see a lot of people are joining. Very nice. Okay, so the first question coming on your screen. So I'm starting the quiz. The first question is going to come on the screen in 1 second. So you are solving, you're looking at a limit question. Limit x tends to 1 upon ln x minus 1 upon x minus 1. You are getting 2 minutes for this question. I'll also give a hint on this question. It is a form of infinity minus infinity form. So you have to take LCM and make it combine and get it into some other form so that you can apply Lapitel's rule. That's the hint I'll give. I'll zip my mouth because then it is not quiz, right? It is like I'm helping you to do anything. So come on, guys. What do you guys think? Come on. You are left with 1 minute, somewhere 10 seconds. So 70 seconds and counting. First, you need to check the form of the limit and then you are supposed to solve it. So I can totally see this is of form infinity minus infinity. Hint I have given, you have to take LCM and then go Lapitel's rule approach or go Lapitel's way. Come on guys, last 40 seconds left. A lot of people are giving me sad reaction. Some of you guys are laughing. Okay, any hearts for this question? Anybody is giving me hearts for this question? Let me add some spice to this question. It is a GATE 2021 question. What do you think more? Come on, is it really exciting to know it is a GATE question 2021? What do you guys think? Last 15 seconds, and I'm going to see that how are you doing on this question. How many of you got it? How many of you got it right? How many of you got it wrong? Let's see who has answered faster. Last, I think it's there. Okay, time is up. Let me show the leaderboard. So Urvesh has got it, 63 points, and I think Urvesh, big hand. I think you are the only one who got it. This is nice. It's a GATE question. Okay. Let me. Okay, I think question. Question 3 on the screen, guys. Let f is R2R such that f of 1 equal to 3 and f dash 1 equal to 6. Then find the value of limit x tends to 0, f of 1 plus x by f of 1 to the power 1 by x. Okay, what do you guys think? Options are 2, option B is e to the power 2, option C is e to the power minus 1, and option D is e. If you see this question very clearly, you will be able to see f of 1 is 3 and they have also given f dash 1. First of all, you need to verify the limit form. It is, I think, 1 keep on infinity form, and you know the formula I have given to you guys. You can use the formula and get the right answer. Come on. Last 30 seconds remaining. What do you guys think? Any reaction for this question? It is not a GATE question, I would say. It is a question from my side, right? What do you guys think? What is the answer? Last 10 seconds, guys. Last 10 seconds. Now 5 seconds. Okay, I think time's up. Let me see the leaderboard here. Wow. So I see 4 of the guys have got it correctly. And let me show you the leaderboard for this. So Kavyashri has got 84 points, and I think this is a good time to congratulate Kavyashri. Big hand for Kavyashri. Guys, I think there was a little glitch here, but I think 2 questions and the winner is Kavyashri. Can I see some congratulations for Kavya in the chat? Big hand for Kavya. I think amazing. Now, if you have any doubt in these 2 questions, we can discuss it, guys. I think we should discuss at least question number 1 on the live quiz, because live quiz, this question number 1 is amazing question. And let me discuss this before we complete our session for the day. So guys, see, this question is a GATE 2021 question. Branch I don't recall, but it is a GATE 21 question, guys. And if you put the limit x tends to 1 here, so you will get 1 by ln1, which is 0, minus 1 by 0, so you will get infinity minus infinity form. So what you are supposed to do, as I was very loudly, I am telling that, very loudly I was telling that you have to take LCM. So you have to combine these 2 guys, and then you will get what? X minus 1 minus ln of x, right? Okay. Then if you see this, so it is what form now? The form has changed from, so it is what? 1 0 1 0 0 by 0 form. Can you guys see that? So applying Lapitel's rule, so apply Lapitel's rule, so you will differentiate it, minus 0 minus 1 by x. Go very slowly, don't get excited. This is product, you have to apply UV rule. So 1 by x, don't be excited, go very slowly, else you will do a mistake. And then it is 1 minus 0. I am not excited, I am going very slowly. and I think that's how Urvesh must have done it. So it is 1 minus 1 by x upon what? 1 by x into x minus 1 plus ln x, guys. Come on. So far so good, guys. Again, if you put x tends to 1, it is still a 0 by 0 form. You can see that. So you have to go one more time. You have to differentiate one more time. It's a classic question of Lapital Rule, right? So we will differentiate one more time. It is minus of 1 by x. Differentiation is what? Minus 1 by x square. Don't forget this minus upon. Then UV rule. So minus 1 by x square, x minus 1. Apply UV rule here. Plus, keep it as 1 by x, and it is 1 minus 0, and then ln x differentiation is 1 by x. So guys, these two terms are coming from UV rule of these two product of functions, okay? And then this yellow guy is coming from ln x, okay? Now if you simplify it further, so limit x tends to 1, you get 1 by x square upon, then it is what? So I would say minus 1 by x square, x minus 1 plus 2 by x. Then put the limit, it is 1 because x tends to 1. Then it is 0. So this guy is 0 anyway because x tends to 1. This part will be 0. So it is what, guys? 0.5. Who got 0.5? Maybe you might not have got in the time I gave, but did you guys get it anyhow? Who got it anyhow? Maybe the timer was up. Maybe you could not get it in the live quiz, but did you really get it on your own? I would like to see some yes. Anybody? Okay, so I think some of you guys might have got it wrong. If somebody would have entered in place of 0.5, it's more of a technical glitch in the, I would say, in the tool. If you put 0.5 in place of 0.5, you just put 0.5 in the answer, it might be wrong, right? So if somebody has got 0.5, and if you put 0.5, now 0.5, and if you put 0.5 in the quiz answer, it would have been wrong. So don't worry, it is not wrong, you have got it right only. Now the next question is a classic question and the last question for the discussion. Let me discuss the second question. So this is also a very good question, guys. So if you look at this question, right, f of 1 is 3 and f dash 1 is 6. If you put x tends to 0, excuse me, so you get what? F of 1 upon f of 1, right, to the power 1 by 0 infinity. This is anyway cancelled, so it is 1 key power infinity form. And you guys are my students, right? You know how to crack this question. You will go on the e key power limit x tends to 0, right? And then you know that this is your f of x, so you'll write 1 by x, come on guys, and then you write f of 1 plus x by f of 1 minus 1. So what I'm trying to say, guys, this is your f of x, don't forget it. This guy is your what? G of x, don't forget it. So what you are doing, g of x is coming down, let me highlight here, and then you are subtracting minus 1 from f of x. Can you guys see that with the color coordination? And don't miss it that it is all e to the power, okay? So if you solve it more, so you can go a little more here and you can write f of 1 plus x and do this minus f of 1 upon x times f of 1. And if you put the value x tends to 0, it is of 0 by 0 form. What is 0 by 0 form? This part is only 0 by 0 form. So what you can do, you can apply and you can solve it outside of the e to the power. That's why I'm changing the color, and apply Lapital Rule. So if you differentiate it by chain rule, you will write f dash 1 plus x into chain rule, apply chain rule. So you will get 1, differentiation 0, x1, so it is 1, minus f of 1 is a constant, differentiation is 0, divided by, apply UV rule here, so it will be what? 1 into f of 1 plus x into 0, so it is anyway 0. So ideally you are left with what? Limit x tends to 0, f dash 1 plus x upon f of 1. Put x tends to 0, you will get f dash 1 upon f of 1, which is 6 by 3. Why 6 by 3? Given f dash 1 is 6, f of 1 is 3. So what do you guys get? 2. So if you get 2, so answer is what? Don't write 2 here, because if you write 2, it is wrong. And that's the reason I have given this option to get trapped. If somebody has got trapped like this, you can blame me. Gate will also do that. So don't get trapped. The right answer is what? E की power 2, which is e square, option B. Did you guys like the question in the quiz? What is your feedback, guys? Did you guys like the question in the quiz? Interesting questions. There was one more question. Because of some glitch, I could not do it. So I'll give as a, you can take it a screenshot, and I think it is already covered here. So that is the reason it was moved from there. We have already done this question. It was somehow mentioned the quiz. Answer is 100. We have already seen this question from GATE 2021. Now I want to give one question as an engagement question for you guys, and I kept it as a placeholder to see that who are my sincere and genuine GATE aspirants and who is going to solve and comment in the chat. And the question is from GATE 2014, as you can see on the screen. As you guys can see on the screen, take it as a screenshot. I would like you guys to do it in your leisure time. You can do it today, you can do it tomorrow, the day after tomorrow, but please ping the answer in the chat. I'll come later and respond to your answer that it is right or wrong. It's a beautiful question, guys. And then I will put some comments so that you will understand the beauty about this question. It's a brilliant question from GATE 2014, IIT Kharagpur time when the paper was organized, or the GATE was organized by the 2014 was organized by IIT Kharagpur. They asked a question on the minimum value of the real valued function x to the x minus 1 to the power 2 by 3 occurs at x equal to option. They're not asking the minimum value. Don't get this wrong. They're asking minimum value of the function occurs at what x value. So options are minus infinity, 0, 1 and infinity. I want my, at least Kavya, I expect you from that you do some solution for this and put it in the answer. Mojesh, Urvesh, these guys who are so active, and definitely I'm asking everybody out there to do this question and tell me the answer. It's a great question. Don't Google and tell me the answer. Solve and then tell me the answer, and then I'll tell you amazing fact about this question. Now I think this is a good time to do the closing note for the session. I'll talk about the weightage for these two important topics from calculus, limits plus maxima minima. My dear GATE aspirant, you can always expect minimum 1, maximum 2 questions from this topic. Nobody can stop it. So when it is a 1 question, you can expect 2 marks. When it is 2 questions, you can expect 2 marks or 3 marks. So weightage is at least 2 marks or 1 mark. You will definitely get 100% every year. So you cannot ignore this. I think without calculus question, that two limits and maxima minima, I really feel that it will not do justice. But I think recently GATE has changed some syllabus. You should take a look at it. But I believe in 2021 paper has, syllabus has got changed little bit. They have played with mathematics portion here and there. Don't worry about it. I believe, still strongly believe, limits and maxima minima is one of the winners in differential calculus. Integral calculus, let's keep it separate. In differential calculus, definitely it is having a high weightage. Okay, so I think we are left with some 5 minutes to discuss the next agenda for the next session. So guys, I'm going to come up again tomorrow for amazing topic from linear algebra. Anybody knows what is that topic? That topic is eigenvalue and eigenvector. I believe in the recent timelines, right? I think last 2-3 years, I have seen GATE is asking every year one question on eigenvalue and eigenvector. So I don't think that you should even think about missing the session. So same time, you have to come log in, and I will be seeing you guys once more on eigenvalue and eigenvector. And then I think in coming time, I think it is 11th October, I guess. There we are going to do a 2-hour session on random variable. What do you guys think? So timing will be same, no change in timing. We don't want you guys to get trouble with that. So timing is all the time same. I think we are going to come tomorrow at the same time with eigenvalue and eigenvector. So thank you for joining this session. One sincere request to you guys, please like and subscribe and support us, because it's like we are putting a lot of time and effort, and it's always good to give it back. So when I try to learn something from here and there, let's say I can take an example. I was trying to learn Django, I think last year, this time. So I did subscribe a lot of amazing channels. So I hope you enjoy this session. And I think this is the second session on GATEvantage series. take maximum benefit out of it and keep supporting us. Without your support, nothing is possible. I think if you keep supporting us and then you get some benefit out of it, and I hope and I pray that you get a very good rank in GATE 22, and it will be really amazing to see that you guys succeed in GATE exam, and we can also be part of your success story. So on this note, guys, thank you very much. If you have any question, last 1-2 minutes, stay back and ask. Any question not related to maths, related to something else, definitely ask. If you are facing any challenge, any issue, keep commenting here. I think the team will always get back to you and answer those questions. But if you have any mathematical question left for me related to these two topics or any other topics, you can ask before we close the session. So Mrityunjay has already solved this question. That's what I can see. You are saying answer is option C. Okay. I think you're right. So Mrityunjay, I think you're right. Very good, brother. It is right answer. Okay. So I hope you guys enjoyed the session. If there is no any other question, we can close the session. Thank you very much. Thank you, guys. Thank you. Take care. Bye-bye. Good night. And Mojes is asking question. Okay, I'll just take up this question. Mojes is asking, sir, do we have a session on probability? Yes. So I think you are answering. You are asking question that whether we are doing probability or not. So in mathematics, we are doing random variable. Given that random variable is going to be very, very important and it is little tricky. So I thought to take it random variable as one of the key concept in maths. So probability, I have no idea as of now. We are planning or something, but definitely your feedback is taken. We'll look into that. Thank you. Okay, guys. Thank you very much. Take care. Good night.